Welcome. In this e-learning, you will learn about why a system-level view makes all the difference in asset reliability. Meet Ben. He is a reliability engineer responsible for keeping assets running safely and reliably. But assets don't operate in isolation. Traditional structures force him to look at equipment one by one, even when everything is connected. Take a solar plant. It's not just a collection of panels, but a system of PV fields, inverters, power distribution, monitoring and control components, and grid infrastructure. When one part fails, the impact can ripple across the whole system. Without system-level visibility, root cause analysis is slow and inconsistent. That's why Ben relies on industrial systems in SAP Asset Performance Management. They give him a structured view of how components work together, so he can detect failures faster, assess risks more accurately, and scale maintenance effectively. But what exactly is an industrial system, and how does it help Ben analyze complex operational behavior? An industrial system is a group of interrelated components, called system elements, that work together as one unit within a specific context. Each system element can also be an industrial system on its own. In SAP APM, the industrial system acts as a system-oriented master data object that complements the technical object structure maintained in ERP. This enables a modular, consistent, and performance-focused view of complex asset environments. To ensure clarity and standardization across all these structures, SAP APM supports modeling based on IEC ISO 813462 concepts. This standard defines three complementary perspectives through which any industrial system can be viewed. Function structures describing the function of an object. Product structures describing the components that fulfill the functions. Location structures describing where the object is located or mounted. Each top node in an industrial system structure is assigned to one of these aspect types. This allows multiple views of the same system and ensures that engineering, maintenance, and operations teams speak the same language when navigating system components. With this foundation, Ben can model real-world operational complexity in a way that is structured, transparent, and scalable, giving him a much clearer understanding of how assets behave as a system and enabling better maintenance decisions across the entire plant. Now that we understand why industrial systems are so important for Ben, let's look at how he actually builds and manages them in SAP Asset Performance Management. All of this happens in the Manage Industrial Systems application. Before Ben can work with industrial systems, they must be enabled in the Configuration Manager. Industrial system categories can also be configured to define how industrial systems are structured in APM, including the available aspect types, supported relationships, and assignment rules for equipment and functional locations. More information about both setup steps is available in the linked videos. Ben starts by opening the app Manage Industrial Systems. Here he gets an overview of all existing industrial systems, with built-in filters, sorting options, and grouping tools that make it easy for him to browse and organize the systems already in place. When Ben needs to create a new industrial system, he selects Create and then New and enters the basic information such as the system ID, a meaningful description, and the long text. He also chooses the industrial system perspective, which defines the operational context of the system. Depending on the use case, Ben can select whether the system is based on an equipment, a functional location, or a plant. Once the perspective is chosen, the corresponding perspective object becomes available for selection. For the solar plant, Ben works in the equipment perspective. This allows him to directly assign individual equipment objects from SAP ERP to the industrial system. As you can see here, the system includes multiple solar panel units, all classified as high-value equipment. By anchoring the industrial system to these specific equipment objects, Ben ensures full traceability between the system model and the physical assets in the field. The industrial system ID can be entered manually or rely on a coding mask to maintain consistent naming conventions across large asset portfolios. If Ben wants to accelerate his work, he doesn't always have to start from scratch. By choosing Create and then from Template, he can reuse predefined system templates maintained in the Manage Industrial System Templates application. These templates already include recommended structures and hierarchy logic and can be reused as soon as they are released. But templates don't just speed up creation, they also keep systems consistent over time. When a template needs to be updated, Ben sets it to under revision, makes the required changes, and releases it again. This activates the push changes option, which lets him propagate the updates to all industrial systems that were created from that template in one step. Release systems are automatically updated and re-released. The sync status is displayed as synchronized. This action runs as a background job, handled through the Job Manager application. Ben can track its progress there and continue working in the meantime. For larger or more complex systems, Ben often relies on Create from Excel. SAP APM provides a downloadable Excel template that makes this process straightforward. The Excel sheet includes all relevant sheets, such as overview, function, product and location hierarchies and relationships. Ben simply downloads the file, fills in the required information, and uploads it to create the full industrial system in one step. Like the push changes process, this import also runs as a background job. Ben can monitor its status in the Job Manager. Once the system is created, Ben can review and edit its general details, including multilingual translations. By maintaining translations in the system, users automatically see descriptions in their login language whenever available, improving usability across global teams. To build the structure, Ben switches to Edit mode. Ben can add top nodes using the plus icon. These top nodes form the foundation of the aspect-based hierarchy and define whether a branch of the system follows the function, product, or location perspective. In the solar plant system, you can see this clearly. The structure is organized across all three aspects, with functional elements like energy generation and monitoring and control, product elements like electrical equipment and generation storage types, and location elements like PV field areas and buildings and structures. Under each top node, Ben can add system elements, which automatically inherit all relevant attributes from that node. System elements represent the individual components of the system, yet each of them can also be a system in its own. This allows Ben to build deeply nested multi-level hierarchies that accurately reflect how complex industrial systems are structured in reality. To support larger updates or mass changes, Ben can use the Excel integration. By navigating to System Structure, he can choose to export the entire structure into an Excel file. This makes it easy to update, reorganize, or extend the hierarchy directly in Excel and upload it back into the system. Whenever Ben wants to explore a specific node or system element in more detail, he can tap the Info icon. This opens several sub-tabs that provide different types of insight. The General Information tab shows the basic attributes, administration, and translation details of the selected node. The Relationships tab allows Ben to view and manage how this element connects to others within the system. These relationships follow predefined types, such as child of, realized by, located at, or instantiated by, ensuring a consistent structure across the entire model. If the system element belongs to the function aspect, Ben can access the Additional Attributes tab. Here, he can enrich the functional view with attributes like failure data profiles or functional failures, giving him a clearer understanding of how the system behaves under specific operating or failure conditions. When a system element belongs to the product aspect, Ben can open the Product Individuals tab. Product individuals represent real technical objects from SAP ERP, such as equipment or functional locations, that instantiate a product aspect system element. As you can see here, a solar panel unit is listed as a product individual, directly linked to the corresponding system element. This allows Ben to link several technical objects to a single element, creating full end-to-end traceability between the industrial system model and the operational assets it represents. In addition to reviewing details, Ben can also manage the lifecycle status of individual system elements. Industrial system elements can be activated or deactivated depending on their relevance. Newly created elements are active by default, but if Ben wants to prevent a specific element from being used further, for example in recommendations or follow-up processes, he can deactivate it. Deactivated elements are hidden from selection and no longer available for processing. To do this efficiently, Ben can work in either the graph view or the table view. The graph view lets him activate or deactivate elements one by one within the visual hierarchy, while the table view allows him to select and update multiple elements at once. Both views help Ben maintain a clean and accurate system structure, and give him full visibility from the top level down to the smallest component. It is also good to know that industrial systems follow a clear life cycle. When Ben creates a system, it starts in the created status and cannot be used in downstream processes until it is released. Once a system is released, it becomes available for further work. If adjustments are required, Ben can reopen it to create a new version, while the previous one moves to obsolete to keep all processes consistent. This life cycle ensures that industrial systems remain controlled, transparent, and version safe. APM also maintains a detailed change log for every industrial system, so Ben can always see who changed what and when. This is especially valuable when multiple teams are involved. With that, Ben has everything he needs to build, maintain, and evolve industrial systems that reflect real-world complexity and make better reliability decisions as a result. Now let's see how Ben puts industrial systems to work in practice. Ben has recently been receiving repeated warnings about inconsistent performance across several interconnected components of the solar plant's energy generation and power distribution subsystems. Individually, none of these components appear critical, but together, their combined behaviour suggests an emerging reliability risk. Instead of generating multiple equipment-level recommendations, Ben creates one system-level recommendation tied directly to the industrial system. He fills in the basic details and sets the type to proactive. What's important here is that Ben does not have to assign individual technical objects one by one. He can directly reference the industrial system as a whole, capturing all affected components under a single structured action plan in one step. Once the recommendation is created, Ben releases it and is ready to implement it. This feeds the findings back into the asset strategy, closing the loop between operational behaviour and maintenance planning and making the solar panels more reliable over time. Ben started with a reliability risk that was invisible at the equipment level, only visible when looking at the system as a whole. With industrial systems in SAP Asset Performance Management, he was able to model the solar plant's complexity, identify the issue in context, and take structured action. Industrial systems give reliability engineers like Ben the foundation they need: a clear structure across function, product, and location, full traceability between the system model and the physical assets, and a direct connection to recommendations and asset strategy. Whether you are managing a single plant or a global asset portfolio, a system-level view is what turns data into decisions. Thank you for watching.